Alright, in this video we're going to define a few more terms related to electricity that you need to know before we move on. Those three terms are volts, amps, and watts. So starting with volts, volts are the electrical pressure. It's a measure of electrical pressure as it passes through a conductor, much like the copper wire we talked about earlier. Amps is the amount and the rate of electricity that is being passed through said conductor. And then lastly, watts is that total power and force of the volts and amps combined. So if you think of a water system, water is a really great analogy for electricity. You can't see electricity, but you can see water. So think of a system where there's a water tank and there's plumbing and water lines, and the water shoots out at the end and makes an old school like powder mill wheel turn. So the volts, again, are the water pressure. It's the electrical pressure, but in the analogy, it's like water pressure. So the more volts you have, in comparison, the more water pressure you have, the faster it shoots through the system. Amps is how much water is present. So consider using a garden hose versus a fire hose. In the garden hose, the amps are a lot less. Even though the pressure can still be high, there's just not as much water present as there would be with the higher amperage fire hose. And then lastly, with the watts, the more volts and amps you have together, the more force and power that the electricity can do, or in our analogy, the water can do. So I used the stone wheel earlier. We'll eliminate that analogy and instead we'll think back to the garden hose and the fire hose. So with the garden hose, you might have high volts, a lot of pressure, but you're going to have low amperage or amount of water. So with that, if you were trying to put out a fire, sure, you could get the water there probably, or close to it, but there's not going to be physically enough of it to get a lot of the job done extinguishing the fire. However, if you hook up to the fire hydrant, now you have a lot more volts, water pressure, and a lot more water, the amps, and so now you have a much greater wattage and force of power that you can use to shoot all of that out and eliminate a fire. Hopefully that makes sense. We'll try it, we'll watch it, we'll see. Again, volts are the electrical pressure, amps is the rate or the amount of electricity, and then watts equals volts times amps, also known as the West Virginia formula, and that is the total power and force of the combination of electricity.